Hello and welcome to cosecant, secant, cotangent, part 2. I'm starting with an example here, and it reads, we're given that the cotangent of theta equals 3, and our job is to find values or value of cosecant theta. So I like to draw a picture, and the first thing I'm going to do is try and use this information, these little clues provided, to get a decent picture. Now I see it says cotangent of theta equals 3. Now 3 is positive. So by using the cast rule, that tells me which quadrants to kind of draw my terminal arms. I could be in this quadrant because there would be a positive 3 or a positive number, and I could be in this quadrant because cotangent is positive in both quadrants. So I'm going to draw a line for a possible terminal arm over here, and it doesn't have to be perfect. I'm just going to put a line there, and then I'm going to put another one over here because there's no reason I couldn't have my terminal arm in this quadrant. So if I construct a little triangle now, actually let's start with this one here. Okay, and this would be theta. Then the information that they've provided says the cotangent would be 3, and that means that the adjacent side would be 3 and the opposite side would be 1. Now, I'm going to do the same sort of information over here. Okay, build my little right triangle, and here's my reference angle, and I would have to have an adjacent of 3 and an opposite of 1, but given where I am, I'm going to make that negative 3 over negative 1. Okay, that's still going to be positive 3 and put me in this quadrant. So that looks pretty good. Now I'm going to fill in what the hypotenuses are just using Pythagoras' theorem. So if I do that, I should get the square root of 10. Okay, so really, when you do this, the real work is done because now I can just rattle off what the answers are. If I look in quadrant 1, okay, then the cosecant of this angle, well, it would be the reciprocal of sine. Sine is 1 over root 10, so it would be root 10 over 1, or just root 10, and it's positive. Now that's a definite good answer, but I also have the answer in quadrant 3. So if I look at this reference angle here, sine is negative 1 over root 10, so cosecant would be root 10 over negative 1, or just negative root 10. And there it is, all done. So nothing to it. All right, let's go do one more example. In this example, we are given the following. We are told that the cosecant of theta is equal to negative 2.37, and we're told, given this information, to find theta, or a possible value of theta, and we're told we're limiting it between 0 degrees and 360 degrees. Now, of course, we have to do that because otherwise there are an infinite amount of answers, because you can always say, oh, here I found it, and then I'm going to add 360 to that, and another 360, and another 360, and so you could have an infinite bunch of answers. So what do we do with this thing? Well, I think the first thing I'm going to do is draw a picture again. I'm going to see if I can paste in my little grid. So there's my grid. And let's have a little look. This is a cosecant, which is negative. So if I use the cast rule, very quickly identify which quadrants I would be in. Cosecant would be negative in this quadrant and or this quadrant. So now let's build some terminal arms. So we could have a terminal arm here, say, and a terminal arm over here, let's say. All right, so now let's build our triangles. So build a little triangle up this way and build a little triangle up this way. And of course these triangles are congruent to each other. Using these reference angles here, we're going to now take this information and say, well, the cosecant is supposed to be 2.37, negative 2.37. Now, if I put that over 1, then it's easier for me to fill in two sides. Now, sine would have been opposite over hypotenuse. This is cosecant, so it is hypotenuse over the opposite. So I got to go 2.37 over 1, and I'm going to make that a negative 1. Okay? You always consider the hypotenuse to stay positive. I'm going to build the same thing over here. I want my hypotenuse over my opposite side. Now, I can fill in these little sides here using good old Pythagoras. Wait a minute, I don't even need those sides there. Never mind. Okay, now what I'm going to do is this. I'm going to take a look and say, hey, I can just look at my drawing and say the sine of theta would therefore be, let's start with the triangle on the left here, would be opposite over hypotenuse. Okay, now how can I solve this for theta? Because after all, that's what I'm asked to find. It's theta. Well, I'm going to get rid of the sine here by using sine inverse of both sides. So here's the work I'm doing. Sine inverse of this, and then sine inverse of this stuff. Okay, so that undoes the sine, and I have a basic answer for theta. And the calculator spits out the following, negative 25 degrees. I guess it really didn't matter which triangle I was visualizing, since the signs were negative in both of them. And here's what the calculator did. It went for this one and threw in here negative 25 degrees. So I look at that and I go, hey, that's pretty good. Now I know what these little reference angles are. They're both going to be 25 degrees. And now I just got to build answers that are between 0 and 360. So now that I've done all the thinking, how do I build up where this terminal arm is? You know, I want to basically say, what do I do to get to here? Well, it looks like I would do 180 plus 25 more. So one of my answers, I think, is 180 plus 25 degrees, or 205 degrees. And then the other answer would be, how do I get all the way to here? Now, I think the easiest way to do that is to say it's like a full rotation of 360, and then I just back it up 25 degrees. And to me, that's the easiest way to tackle that. So that's going to give me 335 degrees. So that meets the requirements, being between 0 and 360, and these are our two answers. Okay, and so that's where I'm going to stop for now. We'll catch you later.